In March of 2025, a 6-year-old girl was given a single injection into her spine. Trillions of engineered viruses carrying a molecular tool built to rewrite one letter of her DNA. 7 days later, she was dead. The trial she died in was never made public until an investigation in July of 2026 forced it into the light. This is the gene they were trying to fix. The gene is called CHD3. It sits on the short arm of chromosome 17. It doesn't build a muscle or a pigment. It builds a machine that decides which other genes are allowed to speak. The DNA in a cell isn't loose thread. It's spooled tight around protein cores, like beads on a string. To read a gene, the cell has to slide those beads aside. CHD3 is one of the motors that does the sliding, the engine at the heart of a complex called NERD. Change one letter in CHD3, and that motor jams. The result is Snijders Blok-Campeau syndrome, first described only in 2018. Children born with it have larger than average heads, delayed development, and above all, trouble with speech. It is not fatal. Most live a normal lifespan, and it is vanishingly rare. Around 237 people in the entire world are known to have it. Rare enough that no drug company will ever build a therapy for it. If a cure was coming, it would have to be built from scratch. Here is what made CHD3 so tempting to fix. In this girl's case, the whole syndrome came down to a single typo. One rung of the DNA ladder, a spot where a C should sit, had been swapped for a T. One letter out of 3 billion. And there is now a tool that can change a single letter without cutting the strand in two. It's called a base editor. It clamps onto that exact spot and chemically rewrites the base back. The errant AT pair flipped to the GC it was always supposed to be. No break in the DNA, just one letter, corrected. On paper, it is the perfect fix for the perfect disease. And it works. In mice. In February of 2026, a team led by the neuroscientist Zilong Q published exactly that. Base edit the mouse version of the gene, and the animal's behavior improved. The paper ran in Nature. But the same team had already taken the next step. They packaged the base editor into a virus, a pair of AAVs, to be infused into a child's spinal fluid and carried up into the brain, to turn a mouse result into a human cure. The family paid for it themselves, more than $800,000. The girl, given the name May to protect her, received the infusion in March 2025. 7 days later, her body was shutting down. The cause was thrombotic microangiopathy, a storm of tiny clots, her own blood vessels turning against her, most likely an overwhelming immune reaction to the flood of virus. The hospital's own ethics board would later judge her death definitely related to the treatment. She was 6 years old. What turned a tragedy into a scandal was everything that didn't happen next. The death was not announced. The trial had run not as a nationally approved study, but under a loophole for innovative hospital treatments with little outside oversight. A year later, that Nature paper, the one celebrating the cure in mice, went to print with no mention that a child had already died receiving it. The investigation reported that the risks had been downplayed to the family, and that warning signs in the animal data, liver and kidney damage in treated monkeys, had come before the girl was treated, not after. When reporters finally exposed it in July 2026, Nature flagged the paper, experts called for it to be retracted, and the university opened an investigation. None of this means the tool is the villain. That same year, in Philadelphia, a baby called KJ got a base editor built just for him, but for a different disease, a liver disorder, and delivered a different way. Not a virus into the brain, but tiny fat bubbles carrying it to the liver. Done in the open, under full regulatory watch. He lived. But difference was never the science, or even the delivery. It was the guardrails. CHD3 is a story about how close we now are to editing a single letter of a life, and how the hardest part may not be the biology at all. For the families still waiting, the dream is real. It just has to be done right. The Gene Channel.